So far, we've been naming compounds that were pretty much always metals with a nonmetal or a metal with a polyatomic ion, okay? But that doesn't mean that you can't get two nonmetals to make a compound. Matter of fact, here's the first time we're going to deal with that. Covalent compounds are two nonmetals, like phosphorus and sulfur. Okay, they come from both, the elements will come from this side of the periodic table over here. When there's just two elements, one from here and one from here someplace, and they get together, that's called a covalent compound. Covalent compounds are going to use a set of prefixes. Why don't they get charged? I mean, why can't you just write them out with letting the charge speak for itself? Well, if these are the elements here, notice all of these are pretty much -1, -2, -3. Okay, they all have minus charges from over there, and there's no way you're going to balance that charge out. So you're going to need some other system, and that's this system that's right in here using dis, tris, tetras. So what you do when you create these compounds, you're going to say how many of each of the elements you have, and if there's one of them, it's mono. Two, di, tri means three, like tricycle. Tetra is a hard one because there's no tetragon. Actually, there is a tetragon. It's a square or a rectangle. And if you remember the word game Tetris, that'll help you remember to use the word tetra with four-sided. But pentagon and pentagonal, triangle, pentangle. Well, anyway, pentagon is five-sided. Hexagon, heptagon, octagon. These are the same prefixes we use for polygons, okay? Decagon, nonagon. So if you see that there are elements and you can see what their subscript numbers are, you put that prefix before the element, and you can then name those. So let's give these bottom ones a try here. So the first one here is CO2. CO2 is going to have a symbol of carbon. Oxygen becomes oxide, just like we did above. We just dropped the last two syllables. And we got to put the name for each number. So monocarbon goes right in there. And dioxide goes in here. Monocarbon dioxide. Now, there is a rule that says if the word begins with mono, it's understood and you don't. So at the beginning, you don't have to put this mono there. Oh. I don't know if I can get this or not. There we go. Carbon dioxide is what that one is called. Okay, so carbon dioxide. Okay, this is phosphorus and fluorine, PF. So this becomes phosphorus fluoride. Okay, you got to put the letters that are before here, tetra. Phosphorus tetrafluoride. Okay, how about this one? Nitrous oxide. Nitrogen oxide. Nitrogen's first, that's going to have two of them, so you need dinitrogen. And trioxide. Okay, and the last one, P4O10, is phosphorus oxide. We take a look at that. Let's bring that up. It's tetraphosphorus decoxide. So they're not hard. You just have to remember what these are. What I would recommend is in that same area where you put your polyatomic ions on a 3x5 card, put those mono, di, tri, tetras. So that'll be a reminder. Maybe it's just on the back side or something. You can flip that over if you need it, or right underneath them, and that'll help you to name these last substances that you have on your next portion of your sheet.